All right, we are starting on page 319. We are on module 2, lesson 3 on systems. Topic 2, and lesson 2, um, systems of linear inequalities. For this, our learning goals: use strategies to solve linear equations with variables on both sides of the equal sign. Write a system of equations to represent a problem context, and we're going and solve a system of equations algebraically using substitution. This is going to be a key thing. It requires a lot of steps. One of those steps is what we've learned in the past, which is solving equations, solving a two-step equation. So if you remember from this, we talked about how when you solve a one-step or two-step equation, right, you have to undo things. You have to actually undo order of operations. You have to undo GEMDAS in reverse order. So you might remember this acronym, which is SADMEG. So we're gonna solve the equation by undoing the operations with the variable. I'm gonna start with number 2 here. We're multiplying by -3, we're adding 1. So we're gonna undo that. We're going to undo adding 1 by subtracting 1. And if you remember, when we do this, we have to do it to both sides to make sure that they're equal. Right, -1 or +1 minus 1 is 0. And we're left with, we're going to rewrite our equation, -3x equal to, the right side, 19 minus 1 is 18. Next, right, we're multiplying by -3. So to undo multiplying, we're going to divide by -3, by that exact same sign. We don't change the sign for that. Negative divided by negative is a positive. 3 divided by 3 is 1. So we draw a line here that means 1x or just x. And our final answer here, negative or positive divided by negative is a negative. And 18 divided by 3 is 6. So if you remember, what does this mean? X is equal to -6. That means that is the one value that makes the equation true. That if I were to plug it in here, it would be equal to 19. Okay. All right, anyways, we're going to do also number 3. I wanted to give us practice with one that has a fraction. So here, same exact things, right? We're multiplying. We also have this -3. So let's add 3 to both sides. Right, that's how we move things across the equal sign. I have 1/4 x equal to 21 plus 3 is 24. Now, in order to get rid of a fraction, you need to multiply by what's called the reciprocal. The reciprocal is just a fraction flipped. So if you flip a fraction like 1/4, 1/4 flipped is 4/1. Now 4/1 is just equal to 4. So we're going to multiply both sides by 4 here. I'll multiply 4 here. I'll multiply 4 here. Okay. Now 4 times 1/4 is 1. Technically, all this just cancels out. You're left with x. And then 24 times 4, that gives us our final answer. I'll just give it to you here. That is 96. All right, so if we plug that into x, that makes the equation true. It's the value that satisfies the equation. It would be equal to 21, the right side. All right, so this is going to be a necessary skill for us to complete this lesson. So, right, if you do have questions on the oral, let me know, right? Maybe you try numbers 1 and 4 as maybe you do. Okay, we're going to get to getting started, lining their pockets. So the situation we have here is that 2 people are trying to save money. All right, let's read this. Colleen and Jimmy want to see how much money they can save in one semester by placing part of their earnings each week into a savings account. Colleen already has $120 in her account, but commits to saving $18 each week. Jimmy, he starts with slightly lower. He starts with $64 in his savings account, but will save slightly more money each week at $25 each week. Okay. Number 1, write an equation to represent these 2 people with total amount of dollars in terms of y and number of weeks x that they put money into their account for the semester. Okay. So let's go and write both names here, and then we'll write an equation for that. Okay. So let's start with Colleen since we started. So in slope-intercept form, right, y equal to mx plus b, there is somewhere we're beginning for Colleen, and there is somewhere we're moving or increasing for Colleen as well. So it's y equal to 18x plus 120. The x goes with 18 because we're going to be multiplying, right? X means weeks. We're going to be multiplying each week by 18 because we're increasing, saving more money each week by $18. The next one is Jimmy. Right, he is saving more money, 25x, but he's beginning at a slightly, gets a little bit, doesn't have a head start as Colleen, is plus 64. Okay. So number 2 says, interpret the rate of change and the y-intercept of each equation in terms of the context. Rate of change, just so you know, that just means the same thing as slope. And the y-intercept, that's where we begin. So for this, we're going to say the rate of change indicates the amount saved each week. So Colleen will save $18 per week. I'll put WK. And then from that, I'll put comma. Jimmy saves $25 per week. All right, so that was just talking about the rate of change. Now let's talk about the y-intercept. Right, the y-intercept indicates the starting amount for each student. So Colleen starts with, that is $120. And Jimmy starts at $64. Okay, notice that is not a per week thing, or that's not a rate. That's our initial value. Number 3, which person saves more money per week? So per week, it is Jimmy saves more money per week because his rate of change is 25 and Colleen's is 18. We're just gonna put Jimmy here. And I'll just put that was $25. All right. Number 4, do you think Colleen and Jimmy will ever have the same amount of money in their savings account at the same time at any point within the semester? We're just going to say, for this, it will be yes. Right, Colleen starts with more money. Colleen starts with more money but saves less money per week. So Colleen, we'll just say saves less. And then Jimmy, right? Jimmy starts with less money but then saves more. So we'll just say Jimmy saves more. Okay. Like that's like you saying, let's say you're walking in the hall, right? Someone is coming down the 200s at the end of the hallway. Someone's going the other way in the 200s and they're walking the opposite direction. Like you will intersect at some point. You will cross each other's paths at some point. So that's pretty much what we're saying with this. Number 5, which person do you predict will have more money in his or her savings account at the end of the semester? End of the semester, typically the semester is 6 months, half a year. Right, this I'll leave to you to answer. Do you think Colleen or Jimmy will save more? Okay. At the end of the semester. All right. So let's move on to page 321. So 321, activity 1. It says representing a problem situation with a system of equations. So with that, some key vocabulary terms to talk about. It says when 2 or more linear equations define a relationship between quantities, they form a system of linear equations. Now the key thing here is just the word system. What a system means in pre-algebra or algebra, it's just 2 or more equations. It's just a name for a group of equations. Just like how there's a name for a group of students, we call it a class. A group of fish, we call a school. A group of lions, we call a pride. You get the idea. It's just a group of equations. When you have 2 or more equations, it's just called a system. That's the name for it. And the next thing is a solution to a system. So what does the answer to a system mean? It is an ordered pair. I'll highlight this in red. So what is the solution to a system? It is an ordered pair x and y. So as a coordinate, that is a solution to both equations in the system. So it's an ordered pair that is a solution to both equations. We typically in pre-algebra only use 2 equations. When you go into high school, you'll use more equations, but we only use 2. And it says graphically, when we graph this, the solution is the point of intersection. I'll put that still in red. Point of intersection. Where two or more lines cross. Okay. And as you can see here in our worked example, we see already Jimmy and Colleen's graph. It's already graphed for us. Where they intersect, that gives us the answer, which is the break-even point, or where they have the same amount of money. So in here it says you can determine the solution to the system by graphing the equations. The point of intersection is the solution to the system. So that is right here. Number one, and really there's just one problem here. Determine the number of weeks after which Colleen and Jimmy will have the same amount of money in their savings account at the same time. What is this amount? Okay. So whenever we see something like this, I like to draw a horizontal and vertical line through this point so I can see where it crosses on the x-axis, where it crosses on the y-axis. Okay. So it looks like they will have the same amount of money at 8 weeks. Now at 8 weeks, how much money do they have? Okay. So we have to look at our axes here. It looks like, so it's somewhere right here, but are we going by tens? It looks like this is 20, 40, 60, 80. So it looks like we're going by 20s here. Okay, so if I know that this is 240, right, 20 above that, that means it is $260 they'll have in this at the same time at 8 weeks. But let's write that out for number one. So the graph shows that the lines intersect at 8 weeks. So we'll say at 8 weeks, I'll just put WKS, comma. It appears that both Jimmy and Colleen will have $260 in their accounts. Okay. Now this is all getting to the main idea, which is there's multiple ways to solve a system, right? You can try to graph it. You can use tables to help you graph it, but there's other methods. So it says, in many systems, it is difficult to determine the solution using the graph. There's an algebraic method they can use called the substitution method. So the substitution method, I'll put this in green. The substitution method is a process of solving a system equations by substituting the value of one variable from one equation into the other equation. So we're going to say one equation into the other equation. And we'll put substituting values also. So what it is, it's an equation. You plug in one equation into another equation. So like if you're familiar with like Inception, that's like a dream within a dream, right? This is an equation in another equation. So that, right, there's going to be a lot of steps with this, and we're going to go through really one example here. All right, so let's go to the next page, 322. We'll be finishing up on 323. All right, but let's look at what we have here. So it says to solve a system written in two variables, you need to create a new equation with only one unknown. So what we'll do here, it says like calling Jimmy's equations as a system. It's written here. Now, what we need to say here is this thing, the transitive property of equality. It states when A is equal to B and B is equal to C, what can we say? You can say that the first thing is equal to the last thing. So what I mean by this, let's say I have the same height as my wife. And my wife has the same height as, I don't know, her friend. We'll give him a hat. What can you say about that? We can say that I am the same height as her friend. Okay. So from there, that's what this means. Because what we're saying here is both equations are in a slope-intercept form. You can create an equation of one unknown. If we say that y is equal to this stuff and y is also equal to this stuff from the second equation, we can say that both this and this are equal to each other. So that we're writing an equation where we no longer have y. So we have what y is equal to, and the other equation what y was equal to again. We have this equation where we only have x. And since we only have x, we can now solve that equation. Okay. So number two, what is the expression on each side of the new equation represent? Okay. Now what 120 plus 18x. We wrote it a different way. We put 18x before 120. But the book likes to write it this way. This represented Colleen's, let's say Colleen's savings. So we want to find when Colleen's savings will be equal to 64 plus 25x, or what that means is Jimmy's savings. Okay. So when you solve the equation for x, what will you know? Now, what x represents, or we can go back up to the graph. X represented, right, the x-axis right here, represented time, and that was in weeks. So when we solve for x, we're going to find when both savings, both Jimmy and Colleen, when is an important thing. When the accounts, when their savings accounts are equal, are exactly the same. Is this value of x the solution to the system? No. Right, because what a solution isn't just one variable. A solution is an ordered pair, x and y. Right, the x would represent weeks, the y would represent total amount. So we got to be careful with that, right? It's not just one number, it's two numbers written as an ordered pair. Okay, now we're going to walk through an example here. It's going to be a lot, but we're going to try to break it down. Okay, all right, for the last thing. To begin solving the equation with variables on both sides of the equation, move all the variables to one side. One side, it doesn't matter. It can be the left side or it can be the right side. But the other thing is all the constants to the other side. So constants, those are just numbers like 6, 4, 5, right? They're not variables, right? Because variables, right, those are letters. So like X, Y, L, okay? But let's look at this. So what we have here, and I'm going to just look at the front two lines. We just have this here, right? We have an equation where we have variables on both sides. We haven't worked with this yet. But we have 120 plus 18x equal to 64 plus 25x. Now here you cannot use SADMEG because we can only use SADMEG when we had one variable. In this case, we have multiple variables. But what did they decide to do? They decided to subtract 18x, right? We have 18x here. We're adding 18x. They used inverse operations to get rid of this 18x on the left side. So they decided to move the variables onto the right. So let's put that here. They decided to have variables on the right and constants to the left. So then you have to isolate it, right? So here, 18x minus 18x, that is equal to 0. But now you have this here. You have this equation. 120 equal to 64 plus 7. We don't have only variables on the right side. We have to give this constant right here, 64, on the left side. It's positive, so I subtract 64 to both sides. As you can see, right, we have constants on the left side, variables on the right. And if you subtract this, 120 minus 64, that is 56. So we have 56 equal to 7x. We have constants on the left, variable terms on the right. But the thing is, in order to solve, you need x by itself. So how do I get rid of the 7? Well, it's multiplying. So I'm going to divide both sides by 7. 7 divided by 7 is 1. 1x is the same thing as x. And 56 divided by 7, that is 8. So that is one part of our answer, though. This means these two accounts will be equal at 8 weeks. In 8 weeks, Colleen and Jim will have the same amount in their account. But we're going to figure out what is y, and that's where we have to substitute. Determine the amount of money in Jimmy's Colleen's and Jimmy's savings account by substituting x into either of the original equations. It does not matter. I'm going to take, we'll take Colleen's. Y equal to 18x plus 120. She started with more money, but she's not saving as much. We're going to plug this in for x. So we'll put y equal to 18, instead of 18x, it'll be 18 times 8 plus 120. You can do some scratch work off to the side. But 18 times 8, and I'll do some scratch work. All right, that's 64. And then 8 times 1 is 8 plus 6 is is that 140? Okay. So this is y equal to 144 plus, don't forget this 120. If you add this, right, this will be 100 plus 100 is 200, 40 plus 20 is 60, and 4 plus 0 is 4. So what this means is that they both will have $264 in their account. So let's, as a final answer, because that's not the final answer, what ordered pair represents the solution to the system? Right, it's always x comma y. Our final answer is 8 weeks. Y is $264. That's the answer here. Okay, so what it means is Colleen and Jimmy will each have $264 in their savings account in 8 weeks. Okay. All right, anyways, that's going to conclude activity 1. I know it's a lot. We're going to have a lot more practice with solving one variable in equations, but we'll end it there.